Hello everyone, I am Maheshwari, Assistant Professor, Department of BSc Information Technology. I am going to explain my lecture video about the topic of congestion control inside the TCP protocols. I am going to explain about congestion control in TCP. Congestion is a network issue. Once it happens, it denies the packet transmission. So it will lose it. So the packets may lose or the transmission time will be increased. First of all, what is TCP congestion control? In transmission control protocol, it has several algorithms in order to protect that congestions. Moreover, it happens inside a packet switched network. The congestion is an important factor in packet switched network, which refers to the state of network where the message traffic becomes so heavy that the network will respond the time slow down, leading to the failure of the packet. Once the congestion happens, it leads to the packet loss. Inside the congestion control, we have to consider two more factors. The factors are receiver window size and congestion window size. The first one is receiver window size. It denotes the sender must know. Before sending the packets, the sender should know about the receiver's capacity. That is, how much of data the receiver can forward to the neighborhood node. This is receiver window size. It shows how much data can a receiver receive in terms of bytes without giving any acknowledgement. In this diagram, the sender transmitting a data. That data can be fragmented into a number of packets. That is nothing but numbered from 1 to 10. The TCP which has been stored inside a buffer before sending to the receiver end. The size of sliding window is nothing but we have to analyze the storage capacity of the buffer and also the storage capacity of the receiver's buffer. Here in receiver side, the TCP receiver buffer will helps to store the upcoming packets and sends against to the receiver end. The sender should not send the data greater than the size of the receiver's window. Once we send the packets or data which is more than the capacity of receiver, it cannot be transmitted. So it automatically leads to a packet loss or transmission delay. If the data sent is greater than the size of the receiver's window, then it causes retransmission of TCP due to the dropping of TCP segment. Since it causes a packet loss, so the receiver will again acknowledge the sender to retransmit the packet for knowing about the details of the packets. Hence, the sender should always send the data that is less than or equal to the size of receiver's window. Once the sender is retransmitting the packet, so it takes the time of multiple times of sending same data inside a network. So the network is also busy, and the time which takes to transmit a packet are also increased. The TCP header, hence the TCP header is used for sending the window size of the receiver to the sender. Every TCP protocol can include a header port. Inside a header port, it also mentioned the receiver's capacity. That means receiver storage capacity or receiver's window size. Based on that window size, the sender can decide whether the particular node is suitable to retransmit a packet or not. Based on the conditions only, the sender will further sends or sends the package to the appropriate node, or it will retransmit to the another node. Congestion window. It is the another next factor of congestion control. It is the state of TCP that limits the amount of data to be sent by the sender into the network even before receiving the acknowledgement. The following factors that are things that is to be remembered inside the congestion window. In congestion window, we have to calculate the size of congestion window, and also if we calculate that size, it should be minimal one. Only the sender knows the congestion window and its size, and it is not sent over the link. The formula for determining how to identify the window size is sender window size equal to minimum of receiver window size comma congestion window size. This is the formula which helps to identify the window size of both congestion and receivers. Based on this formula, the sender can decide the packet transmission, about the packet transmission. Thank you.